Okay, so this discovery of purely imaginary numbers has led to sort of like this understanding of a set of numbers that we didn't know about before we knew about these imaginary numbers. And these numbers are called complex numbers. And a complex number is any number that can be written as in the form a plus bi, where a and b are real numbers. Now you may ask, what does that even mean? So up until this point, you knew numbers like 6 and -12 and pi and things like that. Those are all complex numbers. A plus bi would basically mean there's no I on any of those, but they can all be written in that form. These are called pure real numbers. And they're what you've always called just plain old real numbers. Now, the purely imaginary numbers, the ones with square roots of negative numbers, like 3i and 4i square root of 2. Whoops, forgot my I. I said it, but I didn't write it. 4i square root of 2. Or 6i square root of 9, which is 18i. All of these could be written as 0 plus the stuff that's there. So these are called purely imaginary numbers. Pure real, pure imaginary. Now, there are hybrid complex numbers which have a real part and an imaginary part. So those might be things like 2 plus 3i or 5 minus 7i. Now you may look at those and go, how is that a single number? Those are two numbers being added together. In actuality, no, they're not. If you think about the real number sort of equivalent of this stuff, if I wrote 2 plus the square root of 7, you could pull your calculator out, use it to find a decimal for square root of 7, and then add that to 2, and it would be a single number. The same thing is here. If we could actually use our calculator to find the value of 3i, which we can't because I is not a number that can be actually calculated, it's just sort of symbolizing that square root of -1, this would be a single number. It just has two parts, a real part and an imaginary part. So pure real numbers and pure imaginary numbers are types of complex numbers. Now, the complex numbers, just like any other numbers, we need to know how to do basic operations with them, like adding, subtracting, multiplying, and dividing. So if I were to take two complex numbers, say the two that I wrote there, 2 plus 3i, and I were to subtract them from each other. So in a world that's completely just and everything works the way it should do, you would think you know how to subtract these. And you kind of already do because it does work exactly like you think it would. If I were to take 2 plus 3i and I were to subtract 5 minus 7i, that's like subtracting 5 and subtracting -7i, I would then look to combine like terms. And remember, that's how radicals work. You combine like terms. If the thing underneath is the same, we're good. And I is the square root of -1. So basically, I'm going to take the real parts and combine them. 2 plus -5 is -3. And then the imaginary parts and combine them. And this is a single complex number that resulted from the difference of these two. So when you're adding or subtracting complex numbers, you add or subtract the real parts and add or subtract the imaginary parts.